Okay, so I'm now streaming it online on YouTube. Okay. Let me also share my screen. Okay. Share screen. Can you all see my screen?
Yes, sir.
Thank you. So we are going to study data structures and algorithms. And I will be, this course is specially meant for electrical department PG students who generally don't have much exposure to programming. So I'll be discussing, first I will be discussing basics of programming like Python, just the platforms which are available. Okay, I will be using mostly Python in this course. So yeah, so there are my Python videos which are available in case you want to get familiar with Python. I also have, okay, let me first start with this. I'll come back to the Python videos. The reference books which we'll be using for this course are Data Structures and Algorithms, which is a very standard textbook for this particular topic. And then there is another book which is available online. This is a book on algorithms, which also you can consider, but I'll be mostly referring to Data Structures and Algorithms book by Aho, Hopcraft and Ullman. Yeah, so these are the books. Now I come to some platforms which actually are very helpful for programming. One of the platforms is Bash Terminal. If you are using Linux machines or Mac machines, then Bash Terminal is a very it's a very simple way uh, to programming or to do different tasks, especially with big data. When you have lots and lots of data and you want to quickly do some simple operations, let's say search in the, let's say you have got lots and it's a huge number of text files and you want to search something in those files, generally exact search, like you know the exact word and you want to search it, or you want to see how many entries are there in your total database, or you want to extract top 100 entries, or you want to sort the entries. So these are some very basic operations, and Bash Terminal has got very good commands which are very fast, very efficient. So that's why I like this Bash Terminal for big data processing. It's very quick and very easy to understand. And there is a way where you can write programs also. It's called Bash scripts. I'll be discussing them briefly in one of the lectures. What is Bash scripting? And in these scripts, you can write simple Bash commands, which will be executed as a program. Very effective. And in industry, it is very popular. Although in academia, I don't know if many people know about it. But in industry, certainly Bash scripting is very powerful, and it's very efficiently used, or is very frequently used. Then we come to Python. So Jupyter notebooks are there. If you want to install it on your machine, you can use Anaconda. and you can install Anaconda in your machine, and using Anaconda you can install Jupyter notebooks. There are other ways also to install Jupyter notebooks, but Conda is very convenient way, and generally very quickly installs the things without giving any errors or something. And then if you don't want to install on your machine, if you have internet connection, then Google Colab also is a very good option. You can directly go to this web link, which I have given here, and you can start working there. You can directly, it will open the notebook for you, and it will be saved in your Google account. It's a very convenient way to do programming. Now, after this, I will come to the basics of what we are going to study here. So programming. What is programming? What can programs do? So you have some problem in your mind which you want to solve. Then you can use computers to solve your problem, but provided you can, if you can define your problem in a computer solvable way. Not every problem can be solved on a computer, right? But more and more number of problems now are the computers are able to solve. So there's some noise. Mute everybody. Yeah. So what are the problems which a computer can solve? Generally, simple problems are very easy to solve. I will just throw a problem. Search a word in dictionary. Maybe let's make it a little more interactive. Can you suggest some problems which can be solved efficiently or can be solved very quickly in a computer? Yeah. Feel free to speak.
Sir, sorting the student record in academics.
Yeah, sorting
Student records,
students based on their marks,
roll number, anything.
roll number, etc.
Yes, sir.
Okay, yeah, this is also a good problem. You can make a database of all the students in the class, and you can sort them based on their marks or their roll number. Yeah. What else?
So in industries, solving, keeping inventory detail.
Yeah, that is okay. Making a database.
Yeah.
For any purpose, maybe for a class, for an industry, for your inventory, for your employees, etc. And you can do different operations. Let's say you want to search something, you want to sort something. Yeah, these are the problems which you can write a program for. What else? What else? How about how about identifying people in a video or in an image? Right? You will use machine learning for this, right? But yeah, these are higher level applications which are more advanced, which you can do with the help of machine learning, identifying people in an image, etc. So there are different things. Okay, so let's come to the first problem, which is an example problem. Um, can you write a simple program to find the word accept in this following dictionary? So I've given a dictionary here which has all the words listed in order. And now can you find the word accept? So this problem is solvable using programming. Can you make a simple algorithm or a simple program which will solve this problem? Can you suggest a simple program to
Hello,
solve
sir.
this problem? Yes.
First, we have to accept that particular word, and then we have to check each letter by letter.
Yeah.
Mm,
So we can traverse in the dictionary and equate it to that except if condition matches
Yes. Yes.
for iteration or any kind of iteration we can use. For
Yeah.
while.
Yes. Very good. Very good. Yeah.
So
So,
firstly,
huh?
I'm saying so. Firstly, search for a letter, then C, then E, then P, then T, in order. Then we can.
Yes. Very good. Yeah.
Sir, can we separate all the 6-letter words first, then search for the accept word?
Can we separate?
All the 6-letter words among all these given
Yeah.
words.
Yeah. I think
And
that's a good suggestion. Let me write it down. All the possible programs. So somebody said, traverse the dictionary using a for loop, right? Another method you suggested is separate all 6-letter words and then search. Okay. What else? Somebody suggested do character by character search, right?
That's true.
First match A and then right. Any other possible program? Any other way? Okay. Yeah, good. So I will just give one example program, which one of you already suggested that. So how do we write it? You can write it as an algorithm. It need not be in a specific language. You can write something called a pseudocode. So what's a pseudocode? It's basically, it does not follow the syntax of any particular programming language, but it just illustrates your algorithm in a simple language. So an example program is like this. Given a dictionary as a list and given your query that the word accept, now you run a for loop for item in dictionary. So dictionary is a list and it will pick all the elements. If item matches query, it means that item in the dictionary, it matches your query, then you return true, otherwise you return false. Basically, this means when it matches, then you stop the algorithm and then you return a message that yes, I have found this word in the dictionary. And if even after exhausting all the items, you did not find a word, the same word in the dictionary, then you say, no, I could not find the word in the dictionary, right? This is an example program. Now, what is an algorithm? Let us define an algorithm. A finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of effort in a finite length of time. So basically, it should not be infinite loop or something, right? It should be a finite. It should be a finite program. It should have clear meaning, and it should be performed in finite time and finite space complexity. I mean, it should not consume infinite amount of space, memory space, I mean. And this is what an algorithm is. Now, all of which you suggested are some algorithms, right? All of these are different algorithms. But then the question is, which algorithm will you choose to solve your problem, right? Which algorithm will you use to solve your problem? And the answer is computationally efficient algorithms are highly desirable, greatly desirable. So if your algorithms, some algorithm is computationally efficient, what does that mean? It means that it runs in the least amount of time, right? Such algorithms are very desirable. Of course, there are other parameters or other dimensions also along which an algorithm is evaluated or is assessed, but one very prominent dimension is computational efficiency. It means how much time does it take to execute that algorithm? How much space does it take to execute that algorithm? It means how much memory do you need to execute that algorithm? Yeah. Anybody has any questions until here?
Sir, how do we like if we have certain algorithm which takes less amount of time but consumes a great amount of memory, then like how can we make a judgment whether it's a good algorithm or bad algorithm?
Good question. Good question. So generally, it depends on your problem. Let us say you have got a computer which has got so huge amount of memory. So you can compromise with the memory. Means you can say, okay, you can compromise with the memory, or basically you need not put any memory restraints on your computer. You will just say, okay, whatever algorithm is the fastest, I don't worry about memory that much, right? Or on the other hand, let's say you have got a limited memory. Let's say you are running the program on your mobile phone, which has got very limited memory. So there, you have to go for algorithms which may be a little slower, but should not consume more memory, right?
Okay, sir.
I will discuss some more dimensions along which you can assess, or you can finally, ultimately it's your choice. It's not one rule which fits every problem. You have to make a choice depending on your resources. Okay. Before moving forward, I would like to ask one question. How many of you are familiar with Python? Or how many of you are not familiar with Python? How many of you are not familiar with Python?
I am not familiar, sir.
Sir, I'm not.
You can write on the chat window.
Okay.
You can write on the chat window how many of you are not familiar with Python. Okay. 3. Seven people. Okay. So 7 people, almost 1/3 of the class. Okay, 8. Approximately half the class. Okay, half the class is not familiar. Okay, so I will go back to this slide. So if you want to use Python, the fastest way is just go to this website, Google Colab, and you make your notebook and you can start using it. Let me do it. Okay, I have installed Jupyter in my system. So how I access my Jupyter notebook is something like this. Let me share my entire screen. So this is how I access my Jupyter notebook. I will go to my terminal. Let me first close it. I wrote some program. Let me save it and then close it. Okay, so what I do is I will just write here. I will go to the folder where I have put my program, and in that folder I will say Jupyter Notebook. Right, this is the command I run, and when I run this command, automatically my notebook will open. Okay, in your system it should open automatically, but I will open it using this link. So I will put this link in my browser, could be Chrome or anything. And here, this is how the Jupyter, the basic platform looks like. And in this, I have all the notebooks listed. You can create a new notebook like this, but you don't use Python 2. You use Python 3. Python 2 is outdated. Python 3 is the latest one. So use Python 3. And this is a notebook which I created. I can create a new one also, no problem. Python 3. And this opens the notebook, a new notebook. I can give it a name here. Maybe 01 underscore sample notebook. And I can write my commands here. How many of you are familiar with, what do you say? How many of you are familiar with MATLAB? How many of you are familiar with MATLAB? Let me make a. Okay, I have activated the poll. I've got 2 questions. Launch. Tell me if you are familiar with MATLAB or familiar with Python. Okay. Almost all of you are familiar with MATLAB, it seems. And only half of the class is familiar with Python. Okay, those who are not familiar with MATLAB, are you familiar with any other programming language? Can you unmute yourself and tell me? I just want to know what is the current status of the students. The registered students means those who are not registered, they're just auditing the course. They are means all right. They may not answer.
Sir, I am familiar with Java, but I am not familiar with like this MATLAB.
Okay, you're familiar with Java. Good. And the other student?
Sir, family.
Pardon? Are you familiar with any programming language?
Yes, sir. I am familiar with Python and a little bit with C also.
Oh, you already know Python. Okay. So MATLAB and Python are quite similar. That's why I asked this question. So if you are familiar with either of these, then it's easy to pick up Python. Okay.
Sir, familiar with MATLAB, but I've forgotten a lot. and
No
those
problem. No problem. You have done it in the past at least once, so no problem. Okay, let me here in Python, you can define numbers. Just say a equal to 4. That's it. You don't have to define it, or you don't have to initialize it as you do in C++. In C++ or C, you say int a, and then you assign a value to it, a equal to 4, right? Or a is assigned as the value 4. But here you just say a equal to 4, or you can say s is assigned a string apple. That's it. It is done. Then you can say print a. It will print the value of a. Say print s. Print the value of s. In this way, so it is very quick language. It's very easy to implement things here. Of course, in running wise, Python is much slower than C++, because Python is a very high level language. So it may not be efficient for many tasks. And generally, C++ are much more efficient. And therefore, if you want to make, but for research, Python is perfect. Python is very good for research purposes. But if you want to make softwares which require real-time applications, which require real-time or very low latency kind of scenarios, there you would like to work with more low-level languages like C++ rather than Python. So that's it. What does the chat window say? Okay, so this is about Python. Now I would request go through these videos. These videos are very easy, and they just give an overview of basic Python data types. What are integers, floats, and strings, and then lists, and then dictionaries. So I would request go through these, and by the next class, you kindly go through. There are only 3 videos, so it's very easy. Go through these 3 videos and come back for the next class. Okay, for now we will proceed to the theory of data structures. So we saw what are algorithms. Algorithms are just a set of instructions or the programs. Now let's come to the next topic, data structure. Now we are going to more abstract. What is a data structure? A data structure is a collection of variables, possibly of several different data types, connected in various ways. So data structure is like an entity which does many interesting things for you, right? A data structure is a way of organizing data that can be used efficiently and efficaciously. Efficiently means in terms of complexity, time complexity, space complexity, etc. And efficaciously means it does what you want it to do. It is very maybe accurate, or it is very robust or very precise. So it has a good performance. Or gives good results, gives perfect outcomes. Now, different operations are possible on a data structure. Like let's say you see a data structure, let's say a database of your students, right? And what can you do? What all things you want to do with this database? You want to access the data in it, right? You want to access the data in your database. You want to query your data. You want to query, you want to see whether this data exists or not, right? Or you want to update your data. You want to add more students or remove some students. You want to update your database. All these are some common operations which are possible in your data structure. And you can have many, many more operations also. And the advantage of, why do you want a data structure? So that you can write a clean code and also reusable code, which you can use it later for in other places, or others can use it for their own work. So that is what a data structure is. Now, there's another thing called abstract data type. An abstract data type is a mathematical model with a collection of operations defined on that model. So it's a model and you have different operations defined. Now you may ask the question, what is the difference between data structure and the abstract data type? So the answer is an abstract data type, an ADT, is just an abstraction of a data structure which provides only the interface to which a data structure must adhere to. So in simple language, an ADT is just an input-output interface and does not specify how to implement it, right? Let's say you have, I'll give an example. Let's see this example. Let's say an abstract data type is a vehicle. A vehicle, it's an abstract entity, a vehicle. And what are the operations defined on this vehicle? You want to get into it, you want to board on it, and you want to move the vehicle, and you want to unboard from the vehicle, right? Now, a vehicle can be of so many different types, or different implementations of vehicles could be there, right? It could be a bicycle, could be a car, could be a train. All of them, they satisfy the requirements. All of them, they have these operations. We can board on them, we can move them, we can unboard from them, right? So ADT is an abstract data type, which now see, bicycle, car, train, they have their own different constraints. Like how many people a bicycle can hold? Only one person or maybe two persons if you're in IIT. And how many people can a car hold? 4 people, 5 people, up to 10 people, right? How many people can a train hold? Hundreds of people, right? So they are all different data structures, but they all have those same operations. You can board on them, they will move, and then you can unboard from them. These operations are there. So an ADT is like, and also, okay, other difference is that they will have their own different efficiencies, right? They are different. For example, if you want to go on a bicycle, how much energy will it take? It has a different cost, different energy, right? Its cost is, let's say, 5,000 rupees, you will get a bike. And how much energy you will need? So mostly you will not require any petrol or electricity. You can just cycle, you can pedal it and you can go. But you see, car, the cost is different. It may cost you a few lakhs, and the energy consumption, you have to put petrol in it. Train, maybe, I don't know how much a train does cost, maybe crores of rupees. And then you will have different energy requirement. You need to have very powerful electric supply to move a train, or diesel to move a train. So, but they are very different in terms of their how they implement the same ADT, but the ADT is the same, which is a vehicle. Let's look at a similar, let's look one example to explain this concept in some real programming language, let's say Python. So in Python, you can have a list. A list is basically, let me show you what is a list. I will say, let's say a list, my list is simply a list of numbers, 1, 2, 5, 6, 3, 50, 44, 444, etc. So this is my list. Now I can say print my list. It will print the values. I want to see what are the values of, I will say, the first entry. So in Python, the indexing starts with 0. So the first entry is 1. Second entry is 2. And the last entry, I can also use this special kind of indexing. -1 will index the last entry. The last entry is -1. Or if you want to, what's the 0, 1, 2, 3, 4, 5, 6. The 6th entry is, or the 7th entry is 444. Right. So I can access my information, and I want to see if some entry is some, let's say number 6, I want to query. So this is called access. I can access my values there. Oh, add, remove, and index. This is okay. Let me call it as index then. You can index, you want to add a new number, you can say my list dot append number 100, let's say. And then you can print my list. So you see now the list has become, you have appended an entry called 100. And then remove. You want to remove some entry. I will say my del my list. Which entry you want to remove? Oh, okay, -1. The last entry you want to remove. Then you want to print my list. And if you run it, see now the last entry is gone, right? Yeah. So these are in this way we see in the Python list it is doing all those operations. So Python list is a data structure. It has a definite implementation of whatever I want to do. But the abstract data type is called list, right? How you add the entries, how you remove them, how you index them. You can use many other kinds of ways also. And one such way is also called a linked list. So a linked list, what is a linked list? We will see later in the course. But yeah, this is the concept that an abstract data type called list has these operations. And you can implement this list as a linked list or as a Python list or so on and so forth, so many ways. So this is an ADT and these are all data structures. Okay. So taking an example from Python, we saw in the beginning, we saw an example that you are given a dictionary and you want to find a word from the dictionary, right? So if I implement it in Python in the form of this data structure, I will say I can make a class called dictionary, and this class is that data structure, right? And it has got different functions, different operations. This is just for initializing the class. I can say I can pass a list called dictionary into it, and then the dictionary, this list is saved in my data structure or in this class dictionary by saying self.dictionary. So whatever I say self dot, that becomes a part of this class. And now I want to find some entry. Then I will define an operation called find. And self means this dictionary class itself. And then query is the string which I am passing. If you remember, it's called the access, right? Means we used access as the query word. This is a word, a string which I pass to my method. And then this method will run that algorithm, whatever you write, the algorithm, and then it will return either true or false, right? In this case, this is simply doing a linear search where it is going through all the elements of dictionary, and then if you find it exactly, then you return true, otherwise you return false. That's it. So this was a dictionary. This is a data structure which does different operations, right? So this was all about data structures I wanted to share. If you have any questions, you can ask. Unmute yourself and ask.
Hello, sir.
Yeah.
Sir, what is this self?
Self. Okay. When you see Python, in Python you can, if you see those videos, so when you define a class, you will always define your functions in which the first entry is self. It is just by default, means it is just a syntax it has. So basically it means this self you can use inside, like for example, in this function, I want to use an element of my class, which is called dictionary. So I will access that element using this keyword self. Right? When I will say self, now inside this self, all those elements which I'll be defining anywhere else will be there. I can access every element of the class using this self. If I want to access other functions, that also I can access using self dot. Let's say if I define a, let me make another function called define match. If A is same as B, true. I have defined another function called match. I can use this function here. If self dot match query comma item, if they are matching, then return, right? This is, so now I'm able to use another function defined within this class using this self keyword. So that's why the self keyword is very useful. And it's the common structure in Python that you always write self when you define a new function in the class. You always write self. Basically, it means everything in this class can be accessed via this self. Is that clear?
Yes, sir. So,
if you want to know more about it, then just go back to your go to those 3 videos and you will learn the things, and then it will be easy for you to follow this.
Sir, is it pointing to the instance of this class, this self variable?
Yeah, yes. So this
Like
self,
that, see.
yes. So for example, in this case, okay, I will come to that part. Maybe you can watch it in the video. What do you mean by an instance, and what do you mean by the class and an instance of the class, right? So when I don't want to go into it right now because many of you may not be familiar with Python. Maybe once you do your basic 3 lectures, those basic videos you watch, and then you come back and we will discuss more. Okay. Okay, fine. Should we go to the next topic then?
Excuse me, sir.
Yeah.
Sir, regarding the ADT, can we say that it's more of a general idea that what the variable will be doing rather than it being specific to something?
Yes, it's a general idea. Yeah, it gives you it gives you the general concept, and you cannot ask the question what is the computational complexity of an ADT, because it does not give any implementation.
Okay, sir.
So ADTs don't have computational complexity because they just tell you the abstractly, okay, this function should do something like this, but how it does, how much time it takes, how much computational complexity it has, those things ADT does not tell.
Okay, sir. Thank you, sir.
I just asked you, I want to go from here to Allahabad, and can you take me there? Then you will come up with your list of options with different cost, different time taken. You will say, okay, you can take a train, it will take this much time, it will have this much cost. You can take a taxi, which can take this much time, it will have this much cost. You can take a bicycle, which will take this much time and this much cost, right?
Hello, sir.
Yes.
Sir, suppose an ADT solves 5 purposes. Like here we have seen the ADT has 3 purposes. Like we board, we move, and then we unboard.
Yeah.
Like suppose we have an ADT which has more than these 3 operations, and then we have data structures which solves only these 3 purposes. So can we say that data structure is part of this particular ADT? I mean, the ADT acts like a superset, and the data structure solves less purpose compared to the total number of functionalities which can be performed by the ADT.
No, then that data structure won't conform to that ADT, no?
Okay.
Yeah, you have to define more functions inside the DS data structure to be able to. But the general idea is that in ADT, you just define you just tell what all operations are there, and you don't implement them, but data structure will actually implement them. It will, you can do the analysis, what is the complexity of that data structure.
Okay. Okay, sir.
Yeah. Okay. Thank you very much. I've been talking about complexity. Let's see formally what does complexity mean. So this is about complexity analysis. When we say complexity analysis, it can mean two things. One is computational time, other is computational space or the memory. So how much time your program needs to complete the task, and how much memory is required to complete the task. Generally, we will, in this part, I will discuss mostly about the time complexity. And time complexity is measured with, or is one of the ways to measure time complexity is big O notation. So what is big O notation? It is an upper bound on the complexity in the worst case. So let's say you ask me how much time your algorithm will take. I will say it will take approximately this much time, or it will take maximum this much of time. Or I can say, let's say you ask me if you have a dictionary and your dictionary has got 10 entries, how much time will you take to search this word? I will say, oh, it has 10 entries, then okay, I will look at the first entry, second entry, then third. So it will take linear amount of time. Let's say if there are 10 entries, I will take 10 units of time. And that 1 unit is whatever time I take to compare the two words, right? But if you say, okay, I have 100 entries, how much time will it take? You will say, oh, it will just scale linearly. It will now become 100 times or 100 units. And similarly, if you go to 1,000, 10,000, million, it will scale linearly, right? We're using the simple algorithm. So my complexity is of ON, order N. So big O notation is basically used to find out what is my upper limit on my complexity. Now the definition, the formal definition is this. If the running time of a program denoted by Tn, right? If the running time of program is order Fn, then there exist positive constants C and N naught such that Tn is less than equal to C times Fn for all n greater than or equal to N naught. Okay, let me tell you with an example. Come to the same algorithm which we saw here. It was just doing a linear search, right? It will match with every entry in the dictionary and then tell you whether your query term exists or not there. So this is, for this algorithm, what is my complexity? My complexity is ON. Why ON? Because let's say if I have 100 entries, I will take 100, the amount of time needed or a number of operations needed will be n times some value, right? So this means my time taken will be always less than or equal to, for any n, for any size of the dictionary, my time taken will be less than or equal to some C times n. Okay, let me add an example. Linear search, can you see my screen?
Yes.
Yes,
Okay.
sir.
Yes, sir.
Yeah. For linear search, my complexity is ON. What does that mean? If size of dictionary is doubled, my TN also, T also is doubled in general, time taken is less than or equal to, let's say, some constant c times n, right? For all n greater than some n naught. In general, time taken is less than or equal to c. What is c? C can be, let's say, I take 1 second to compare two words. Then this will be 1 second, right? Or it can be 2 seconds. Then it is less than or equal to. Right? Let's say 2 seconds times n. So this means this is my time taken will always be less than or equal to 2 seconds time n. And for n greater than n naught can be 5 or 10 or 20, whatever. Yeah, so that's how. So basically, it tells me as the size of dictionary increases, how will my search become, how much time my search will take. Now, this ON is can be very large number, right? Imagine your dictionary has got million entries or billion entries. Then time taken will be really, really huge, right? Imagine Google search. If Google search has a complexity of ON now, and where n is the number of web pages in the entire web, in the entire internet, in the entire web space, then this n will be very large, right? It may be billions of websites are there. And if Google complexity is ON, this means you type a word, it will take, even if it takes a fraction of a second to compare one web page, but then there are billions of web pages, then this number will be very large, and Google cannot return the result to you in a fraction of a second, right? So that's why this complexity becomes very important factor in determining your algorithm. So this linear search is very inefficient. That's what we get from here. Is that clear? So basically this big O notation helps to quantify the performance of my algorithm as the input size n becomes very large, potentially goes to infinity. Right? Okay, now let's see some common big O notation values. Constant time means when it's a constant time operation. Let's say I ask you whether the dictionary exists or not, right? Does the dictionary exist or not? So I will write an example. Maybe I'll make a duplicate slide. For example, does the dictionary exist? Or does the dictionary have any entries? Right? So what you do, you will just check whether there is any entry or not. Now, it does not matter what is the size of the dictionary. It could be millions of entries or billions of entries, but you access whether dictionary 0 or the 0th entry, is it there or not? If it is there, this means yes, it has an entry. If it is not there, you say it has no entry. That's it. So this will take constant amount of time, no matter how big is your dictionary. So this is constant time complexity. Now, some algorithms can have logarithm complexity. These are not nice because they may take exponential amount of time to do some task. So these algorithms are good, are feasible when n is small, but when n becomes large, then they become very bad. If you have read machine learning, in machine learning, you often study about the curse of dimensionality, right? So this is something similar. So when you have exponential, some algorithm which has exponential time complexity, those algorithms, they don't scale very well. So you don't want to make n very large. Okay. Now you can also have factorial time complexity, which is even bigger, right? The factorial time complexity means it takes factorial n amount of time to complete that task. So that is a very, very large amount of time. Okay, now some properties of big O notation. So big O notation gives you the worst case scenario or the upper limit on time, right? So if you have two numbers, let's say your complexity is of the order of n plus c, or the time taken by an algorithm is of the order n plus c, then you will say my big O notation is simply On. Why? Because c is a constant, right? And if you go back to the original definition, you can always take this c to be slightly more than that c, and then for large n's, that effect is nullified, and you get by definition order n only. Similarly, if you are having a constant c multiplying with your n, then you can say my complexity is order n only. You don't have to consider c, because the c can be absorbed by the c naught or the c of the definition, right? So if your algorithm takes n plus c time steps, then you can simply say my algorithm has linear time complexity. And similarly, if your algorithm takes cn amount of time, then you will say my time complexity is simply n. Okay, this is an exercise for you. Tell me, in this formula, so how you compute the time complexity. So first of all, you will find out how many steps are there in the program. And then if you find that expression, then find the fastest growing term. Let me write it down here. Find the fastest growing term. Right, and that term will tell you the complexity. So in these three terms, the fastest growing term is n square. So therefore, you are saying my complexity is order n square. Now this 8 does not play any role here. Just n square is sufficient. Now tell me, using this similar expression or this similar way, tell me the complexity of this.
It will be also n square.
Yes, sir, n square.
Okay. This is order n square, correct. What about this?
In factorial.
N factorial or e to the power n.
Which is larger, n factorial or e to the power n?
I think e to the power n.
E to the power n.
E to the power n.
Yeah.
Factorial.
N factorial.
So
Yeah.
n factorial.
N factorial is larger. N factorial is larger. So see here, when you increase n, you are just multiplying with e. Like you go from n to n plus 1, you're just multiplying an extra e into it. But here you go from n to n plus 1, you're multiplying n plus 1, which is also a very large number, right? Do you get the logic?
Yes, sir.
Yes, sir.
N factorial is larger than e to the power n. I gave an intuitive understanding of this. Yeah, so this is a factorial order complexity. Okay, now the question is, okay, you understood, if you know this, if you know the time taken or the number of steps in an algorithm, how to find the order of the complexity, right? But now the question is, how do you find this term? So to find this term, you have to see your algorithm properly. So let's take this algorithm. In this algorithm, what is the number of steps involved? So first of all,
Only one loop.
Pardon?
Only one loop.
Yeah, one loop is there, and it has no dependency on n. There is no n in
Yes,
there.
yes.
It's a program which has only 8 steps. It runs the loop has 8 steps, and that's it. So it's a finite loop, finite time, and there is no dependency on n at all, independent of n, right? So it will run in a constant time always. So therefore, the complexity is order 1, which means constant time complexity. Right? It has no dependency on n at all, right? So O1. I don't want to show you the answer before asking how can I. Let me stop sharing for a while, and I will remove the answers. Give me a second. Okay, I'm done. Let me share my screen again and go back to the code. Where is the code? Here it is. Yeah. Okay. So for this program, you found out that it's constant time complexity. How about this?
Big of n.
Order of n.
Okay. So tell me two things. One is what is the actual number of steps, and then you tell me what is the O notation. So let me
N
call it
minus
as
1 number of steps.
huh?
N minus 1 number of no, n number of
Steps. Sir, n by 3 steps.
N by 3. Okay. And this means big O notation will be, right, On. So it has got n by 3 steps. Why you say you start with O? Let's take n as some number, maybe be 100 or something. Then your I is 0, and then you run through the loop. I becomes 3. Again, run through the loop. It becomes 6, then 9, then 12, and it keeps increasing with the multiple of 3, and ultimately it will terminate when you reach 100. Your n, if your n is 100, and how many times the loop has run? It has run basically n by 3 times approximately, right? So therefore you say my Tn is equal to n upon 3. Now when n is very large, then Tn will be really of the order of n by 3. So therefore the big O notation becomes On, right? Okay, now how about this?
It will have 2
n
steps,
square.
so n square.
N square.
Tell me first Tn.
N plus n minus I.
N plus n minus I. Yeah.
No, I think it should be n
Sir,
into
n
n
into
minus
n
I.
minus I.
How did you calculate that?
So because for each I there is a range of j's, that is why.
But what is I here? Here.
I is itself in the range of them.
In your formulation, you have an I, but how can your total time depend on I? I is just a dummy variable. I is just a variable, and it is changing. How can your final answer depend on I?
Sir, for I is equals to 1, the J loop will run from will run n minus 1 times. And for I equals to
Sir,
2,
n
it will run.
factorial.
it will run for n minus 2. So the total number of time it will take is n into n plus 1 by 2.
Yeah. Yeah.
So the big of n will be n square.
Yeah. Yes. So your Tn is this. It is n minus 1 plus n minus 2 plus so on, which is nn minus 1 upon 2 or nn plus 1 upon 2. Yeah. And then you will say my big O is simply how much? How much is big O?
N square.
Yeah. So because this thing was equal to n into, let's say, n plus 1 upon 2. So big O is, yeah. Yes. Is this clear to everybody? Does that make sense?
Sir, can you
Sir,
explain
can you
it
explain
once
the
again?
Tn?
Can I explain what?
The Tn.
The Tn, yes, very good. So let's say you start with I equal to 0, right? I has to go from 0 to n minus 1. When I is 0, then j will go from 0 to n minus 1. So this is n actually, n plus. So this will take n steps. It will go for n times. This sum function will run for n times, right? Then go to the next, this loop has ended, again go back. Now I becomes 1. When I becomes 1, then j goes from 1 to n minus 1, which means total n minus 1 times it will run. So this sum function will run n minus 1 times, right? So I have added plus n minus 1 and we come here. Then again, I becomes 2, j becomes, I think we can write here, right? So I becomes 0, then you can write down everything so that you can be more concrete and you don't make mistakes. Okay. When I equal to 0, then j will go from 0 to n minus 1, and therefore function will run for n times, right? And then I equal to 1, then j will go from 1 to n minus 1, and then f will run n minus 1 times. So in this way, you can finally add up all of them and you get nn plus 1 upon 2.
Okay, sir.
Okay, means it could be n minus 1 plus n minus 1 upon 2, or I don't, means just you can verify that. But for the final answer is on square. Okay. Next example. Now here, this example is little more clever. This is also a search problem, the same dictionary search, right? You are given an array of sorted numbers and you are given val, which is a value you want to find in the array, and you have to return whether this value is present in the array or not. And the array is sorted, just like your dictionary. So the algorithm is, you take something called low, which is 0, and something called high, which is, no, it is not length of array minus 1. It is array minus 1. The last entry. So the low is the 0th, maybe you can call it. Sorry, it was correct. It was correct. These are just the indices. So my these are just the lowest index is this. So low is pointing to here, and the high is pointing to here, the last entry. Now, while low is less than equal to high, which is true in this case, I can write it somewhere, right? When low is 0, high, let me call it just high. High is whatever, 0, 1, 2, 3, 4, 5, 5, right? then mid will become how much? High plus low upon 2. So it is 2.5, and you round it off, it becomes 2. Take the int part. And then if array mid is equal to val, then return mid. Means if my array mid is equal to value, if my the value at 2, 0, 1, 2, 17, if 17 is equal to the val, let's assume some value for val. Let's say val is how much? Let's call it as 20, right? If my array value is, if array mid is how much? 17, then return no, this is possible, this is not true. If it is less than val, then make low as mid plus 1. So yeah, this condition is true, right? My array mid is 17 and val is 20. So this condition is true. So let me change my low. Now my low becomes equal to mid plus 1. So means it becomes 3, right? And what is my high? High is same as 5 only. Now this loop ended. And again, low is less than equal to high. Yes, low is 3, high is 5. So this condition is true. Let me again go through the loop. Now again, my mid becomes equal to high plus low upon 2. So 3 plus 5 upon 2, so means 4, right? Now let's check the value at 4. 0, 1, 2, 3, 4, 35. So my 35 is less than 20. Is it correct or not correct? No, it is not correct. 35 is not less than 35 is not less than 20. So what will happen? Put this one. Now high becomes mid minus 1. So my high becomes 3. Right? Because my mid value is more than val. So okay, so the high becomes equal to 3. Now let's see. Again, the while loop runs. Now again, low is equal to high, so this will again run. Now my mid also becomes equal to 3 plus 3 upon 2. High is also 3, low is also 3. So mid also becomes 3. Then now my array mid equal to value. Is it correct? What is the value here? 0, 1, 2, 3, 21. Is 21 equal to 20? No, it's not correct. Is it less than value? No. Is it more than value? Yes, 21 is more than 20. So my high becomes mid minus 1. Now my high becomes 2. Now again go here. Low is less than equal to high. This condition is violated. My low is more than high. So I will end this algorithm and the value returned is none. None means no, I could not find the number. So this number 20 does not exist in this array. And how many time steps did I need? I needed only 1, 2, 3. 3 time steps. Means complexity, or we can't say complexity because we did for a particular example, but it took 3 time steps to, this algorithm took 3 time steps to find. So if we would have done a linear search, it would have taken how many time steps?
6.
6, because there are 6 entries, so 6 times we had to run the loop. But here it took only 3 time steps. And if you increase n to a very large value, make your array very, very large, maybe 100, 1,000, million entries, and then apply this algorithm, how many time steps will it need?
It will be half of linear search.
Login.
Yeah.
No, login. Yeah.
It's log. You know why? Because you are first hitting the midpoint and dividing it into 2 segments, and then again hitting the midpoint. Your array length is becoming half every time.
Okay,
right?
okay.
First make it half, then again make it half, again make it half. So it comes out to be log n complexity. Right? Let's say your array length is 8, then you will make it 4, then 2, then 1. How many time steps did it take? Log 8 to the base 2. Right? So log to the base 2, 8. Right? That's why it is called log complexity. So order log n. Yeah, that's the thing. I think we can stop here. It's 3:20 almost. Now a practice problem for you. This is ungraded, just for your own practice. Write a code to find if a given word exists in a given dictionary. So we wrote this algorithm for numbers. Can you write such an algorithm for words now? String matching. And I would recommend that you watch the Python videos, Python lectures, and then write a code using Python language that will help you also learn Python better. Yeah. Now one more word of caution, that your algorithm very much depends on your basic operation which you are using. Like here, you can do direct comparison of the word with the, or of the number with the array. Like the value and array can be compared directly, right? The value and the entry in the array, they can be compared directly using this mathematical operator. Now, depending on different languages, they may allow you or not allow you, but it turns out that Python allows you to do direct string comparison. Means allow means it has an inbuilt function to do the direct string comparison. If that were not there, you would have to first, you would have to write a function, this function which we wrote earlier, match function. This match function. So it turns out that Python provides you with this kind of equality checker, but if Python would not have given you, then you would have implemented it in your own way. Means using the basic element wise or character wise comparison. Yeah, in C mostly so many functions are not available. You have to write everything on your own, or you have to use some library, but in Python it's available, so you can use. Okay, now I will just one more comment I want to make. When is big O not a concern? When do you not use big O? So there are some programs which you don't want to run every time. You just want to run maybe once or twice, or maybe sometimes you want to run the program. So there you don't over optimize. You don't waste time on optimizing the code too much, right? For example, in your thesis, you have got some data set and you want to find out, or maybe you want to sort the data set, right? It's a one-time operation. You have to do it only once in your entire PhD career or master's career. So just use any dirty code, or any dirty means any off-the-shelf, anything available, maybe whatever is quickly available. Don't waste time on finding the best method to sort the things, right? Whatever is available in Python or Excel sheet, just use it. So don't over optimize, because it wastes a lot of time to write the code and debug the code. Just go with the dirty solution and quickly get done with your job. So you don't have to worry about the bigger complexity of the program. Whatever is available, you just use it. Then when comprehensibility is more important, for example, you are explaining the concept to somebody, and you want the program to be very comprehensible, means easy to understand by others, then you don't worry about big O notation, and you write codes which are easy to read and easy to maintain. When you want to write codes, let's say, which will be read by many people and maintained by many people. Let's say you're writing a program for your lab, and this code will be used by many other people also in your lab. Then you don't want to optimize it so much that people find it difficult to read. And actually, there are many programmers who do write like that. There are very expert programmers. They can write a long code even in a few lines. But then understanding those codes becomes so difficult that only very expert programmers can understand. But in general, researchers cannot understand. So therefore, in such cases, you may like to go with a suboptimal solution or less than optimal solution, but make it comprehensible. Then there could be other factors such as memory requirement, stability of your code, accuracy of your code. These can also be a concern, and which you want to account when you are writing your program. So big O is not the only concern, but these are also the concerns. Let's say you are implementing a code in your mobile phone where you don't have much memory. So then, and you have an optimal algorithm available which is very fast, but it requires lots of memory, then you won't go with that, right? And then stability. You may write a very compact code, but it may be unstable, which means, let's say, it may break for certain cases, or it may fail for some cases, or it may not give very accurate results. So all those things also you have to consider. But anyway, so this was these things. When you do research, you will face these issues. Then you remember this lesson that big O is not the only concern. You have to take care of other things also. Yeah, that's it. Thank you very much. We can stop here. If you have any questions, you can stay back and ask.
Hello, sir. How can we get our doubts cleared? Like, will it be in forum, or we can mail you?